Welcome to Pioneer's Knowledge Hub.
Have you ever wondered how the sun, a celestial body millions of miles away, can provide so much heat and light to our planet? It's a fascinating question, isn't it? The sun, along with other stars scattered across the cosmos, radiates a staggering amount of power. This immense energy is a result of a process deep within their cores known as fusion energy. Fusion energy, to put it simply, is the energy produced when two light atomic nuclei combine to form a heavier nucleus. This fusion process happens under extreme conditions of temperature and pressure, and when it does, a tremendous amount of energy is released. This energy is what fuels the stars, the sun, and provides the heat and light we experience on Earth. Now, here's a thought to ponder. Imagine if we could harness this stellar power on Earth. That, in essence, is the goal of fusion energy. So why does fusion energy matter to us? Imagine this: a power source so efficient that it could provide energy for millions of years. A solution so sustainable that it leaves no harmful waste behind. A fuel so abundant that it's practically inexhaustible. This isn't some far-off science fiction dream. This is the potential of fusion energy. Fusion energy is incredibly efficient. By harnessing the same process that powers the stars, fusion energy could provide millions of times more energy than traditional fossil fuels. Just to put it into perspective, 1 gram of fusion fuel could generate as much energy as 11 tons of coal. That's the kind of efficiency that could revolutionize how we power our world. But fusion energy isn't just about efficiency, it's also about sustainability. Unlike fossil fuels, which leave harmful pollutants and contribute to climate change, fusion energy is clean. It produces no greenhouse gases, no long-lived radioactive waste, and no risk of a meltdown. It's a solution that could not only meet our energy needs but also help us protect our planet. And then, there's the matter of fuel. Fusion energy uses isotopes of hydrogen, deuterium and tritium, as fuel. Deuterium can be extracted from seawater, and tritium can be bred from lithium, which is abundant in the Earth's crust. This means that fusion energy has the potential to be not just efficient and sustainable but also virtually inexhaustible. In a world facing an energy crisis and the looming threat of climate change, fusion energy could provide the answer. It has the potential to deliver safe, clean, and abundant energy for generations to come. But it's important to remember that this is still a potential. While the benefits of fusion energy are clear, realizing them is a complex and challenging task. There's a long road ahead before fusion energy can become a practical reality. The promise of fusion energy is immense, but it's not without its challenges. Harnessing the energy of the stars here on Earth is no easy task. As we delve into the realm of fusion energy, it's crucial to understand the significant hurdles that scientists and engineers face in making this dream a reality. First and foremost is the technical challenge. Fusion requires conditions of extreme heat and pressure, akin to the core of the sun. We're talking about temperatures in the range of 200 million degrees Celsius, and immense pressure. This is far beyond anything we can naturally achieve on Earth. To put it into perspective, that's over 6 times hotter than the core of the sun. It's like trying to hold a piece of the sun right here on Earth. The second challenge lies in the engineering. To achieve these extreme conditions, we need a device that can contain and control the fusion reaction. This is where the concept of a tokamak, a donut-shaped device, comes into play. The tokamak uses magnetic fields to contain the hot plasma, but designing and building a tokamak that can withstand such conditions is a monumental task. It's like building a bottle, not for wine but for a star. Then there's the issue of maintaining the reaction. Once we've achieved the conditions for fusion, the next challenge is to keep the reaction going long enough to generate more energy than we've put in. This is known as achieving ignition. However, maintaining a stable fusion reaction for a significant period of time is still something we're grappling with. Finally, there's the ongoing research and experimentation. Despite decades of work, fusion energy remains largely experimental. Scientists around the world are tirelessly working on different approaches to fusion, each with their own set of challenges. We're still at the stage of learning, experimenting, and iterating. While the road to fusion energy is steep, the rewards could be astronomical. The promise of a nearly limitless, clean source of energy is a beacon that drives us forward, inspiring us to overcome these challenges and bring the power of the stars to Earth. Despite the challenges, the pursuit of fusion energy is relentless. As we stand on the precipice of a new energy era, scientists around the globe are tirelessly working towards the goal of achieving sustainable fusion energy. In the bustling labs and research centers, The current state of fusion energy research is promising. There are numerous projects and experiments underway that are making significant strides in this field. One such example is the International Thermonuclear Experimental Reactor, or ITER, a collaboration of 35 nations, which is currently constructing the world's largest tokamak, a device designed to harness the power of fusion. Then there's the National Ignition Facility in the United States, which uses powerful lasers to heat and compress a small pellet of hydrogen fuel to the point where nuclear fusion reactions take place. These experiments, among others, are paving the way towards making fusion energy a reality. But when exactly can we expect fusion energy to light up our homes? Well, the timeline isn't set in stone, but experts are optimistic. Some predict that we could see the first fusion power plants within the next 3 to 4 decades. Yes, that's a while away, but remember, we're talking about replicating the process that powers the sun and stars right here on Earth. That's no small feat. The future of fusion energy is bright, and not just because it's about harnessing the power of a mini-sun. It's bright because it promises a source of energy that is clean, abundant, and virtually limitless. It's bright because it could help us tackle some of the biggest challenges of our time, from climate change to energy security. Fusion energy might not be here yet, but the day we harness the power of the stars could be closer than we think. The journey may be long and filled with challenges, but the destination, a world powered by fusion energy, is well worth the effort.
Please do like, share and subscribe to my channel. Thanks for watching.